Meet Marcus. He's sitting at his kitchen table, staring at a city street map for a school project, and he notices something weird. Every time two roads cross, they make these perfect X shapes. He wonders, are those angles related somehow? Spoiler alert, yes, and the relationship is super cool. Today, we're going on Marcus's journey from confused to confident with vertical and adjacent angles. Let's go. So, Marcus is looking at this X on his map, two roads crossing, and he counts the angles. 1, 2, 3, 4. Yup, every time two straight lines intersect, they always make exactly 4 angles. Now here's the exciting part. Those 4 angles aren't random. They come in 2 special types, vertical angles and adjacent angles. These 2 types have a relationship that will blow your mind. Ready to meet them? Here's where it gets really cool. Vertical angles are the angles that sit directly across from each other when two lines cross. They're like twins, always equal. So if Marcus measures the top angle of that road intersection and gets 60 degrees, the angle directly opposite at the bottom is also 60 degrees. Every single time, no exceptions. Mathematicians call this vertically opposite angles, and it's one of those geometric facts that just feels like a superpower once you know it.
Now let's meet adjacent angles. These are the angles that sit right next to each other at the intersection. Neighbors, not twins. Adjacent angles share a common ray, which is just a fancy way of saying they share one of those lines coming out from the center. Here's the key fact. Because they sit along a straight line together, adjacent angles always add up to 180 degrees. That straight line is called a straight angle, and it's always 180 degrees. Marcus just had his first big aha moment.
Okay, let's lock in the 2 big rules Marcus discovered. Rule 1, vertical angles are always equal. Rule 2, adjacent angles always add up to 180 degrees. These 2 rules are your secret weapons for solving any angle problem. See a missing angle? Check if it's vertical, then it equals the one across from it. Or check if it's adjacent, then subtract from 180 to find it. Marcus keeps these rules in his notebook like cheat codes. You should too. All right, let's try the first problem Marcus finds on his worksheet. 2 lines cross, and one angle is labeled 45 degrees. What is the angle directly across from it? Remember Rule 1, vertical angles are always equal. So the angle across from 45 degrees is also 45 degrees. That's it. No adding, no subtracting. Just recognize that those 2 angles are vertical, and boom, they're equal. Marcus gets this one right away. Nice work, Marcus. Now Marcus sees a trickier one. 2 lines cross, and one angle is 120 degrees. What is the angle right next to it? The adjacent angle. Use Rule 2. Adjacent angles add up to 180 degrees. So we write 120 plus question mark equals 180. To find the missing angle, subtract 120 from 180. And 180 minus 120 equals 60. So the adjacent angle is 60 degrees. Marcus double-checks by adding. 120 plus 60 equals 180. Yep, that's a straight line. Perfect. Now Marcus hits the challenge problem. 2 lines cross, and only one angle is labeled 110 degrees. He needs to find all the other 3 angles. Here's how he thinks it through. The angle directly across, the vertical angle, equals 110 degrees. The angle right next to the 110-degree angle is adjacent, so it equals 180 minus 110, which is 70 degrees. And the last angle? It's vertical to that 70-degree angle, so it also equals 70 degrees. All 4 angles, 110, 70, 110, 70. Let's check. 110 plus 70 equals 180. That's a straight line. Correct. Marcus realizes he's been seeing vertical and adjacent angles his whole life without knowing it. Scissors, when you open them, the 2 blades and the 2 handles make vertical angles. Road intersections, like on his map, that's our X shape again, packed with both types. Window frames create neat adjacent angle pairs, even railroad crossings. Once you know what to look for, you'll spot these angle pairs everywhere. Math really is hiding in plain sight.
Marcus can't stop noticing them now. Marcus's teacher throws a curveball, an algebra angle problem. Two lines cross, and one angle is labeled 2x plus 10 degrees, and its vertical angle is labeled 50 degrees. Since vertical angles are equal, we can write 2x plus 10 equals 50. Now solve for x. Subtract 10 from both sides, 2x equals 40. Divide both sides by 2, x equals 20. Let's check. 2 times 20 plus 10 equals 40 plus 10, which equals 50. That matches the vertical angle. We're right. Marcus pumps his fist. Algebra plus geometry equals awesome. One more algebra challenge. Marcus is on a roll. Two adjacent angles along a straight line are labeled 3x degrees and x plus 20 degrees. Adjacent angles add up to 180 degrees. So, 3x plus 20 equals 180. Combine like terms. 4x plus 20 equals 180. Subtract 20 from both sides. 4x equals 160. Divide by 4. X equals 40. Check it. 3 times 40 equals 120. And 40 plus 20 equals 60. Does 120 plus 60 equal 180? Yes, that's a perfect straight line. Marcus is absolutely flying now. Before Marcus finishes, his teacher points out the sneaky mistakes students make. First one, vertical doesn't mean up and down. In math, vertical angles means they're directly opposite each other. Second, adjacent angles have to share both a vertex and a ray, not just be near each other. Third, adjacent angles add to 180, not 90. Don't mix those up. And finally, when you're stuck, label all 4 angles at the intersection. It helps you see the relationships clearly. Marcus writes all 4 warnings in red in his notebook. Remember when Marcus was staring at that street map, totally confused? Now look at him. He can find every missing angle in seconds. Let's recap. Vertical angles are opposite each other at an intersection and are always equal. Adjacent angles are side by side and always add up to 180 degrees. You can even use algebra to solve for unknown values. And the best part? These angle pairs are hiding everywhere in the real world, just waiting for you to spot them. You've got the skills now. Go be an angle detective. Just